Okay, here is an expression, and I'm going to use the distributive property to write that expression a different way. Now, I could approach this using two math practices. One of those math practices could be just using what I know about the distributive property of multiplication. I'm going to write this expression a different way. Or I could say, like number 7, looking at the structure of the problem, I can write it in another way. Now, when I have a situation like this, where we have 5x times 9x plus 7, then what I'm essentially going to wind up doing is multiplying 5x and 9x, and I'm going to multiply 5x and 7. So, when I have 5x times 9x, I know that 5 times 9 is 45, and x times x is what, Logan? What's x times x?
X times x would equal 1x.
No, not just 1x. I got 2 of them. We had this situation a little bit
Oh,
ago.
x squared.
X squared, because anytime you multiply a number by itself, you are squaring it. And since we are squaring x and we don't know the value of it, we're going to say x squared. Then 5x times 7. What is 5x times 7, children? What was 5 times 7? 35, and then I still have that x, 35x. So, if I knew the value of x, I could solve this problem here the way it's written, and I would get the exact same answer as the way it's written here. These two expressions are equivalent, and using the distributive property of multiplication, I was able to rewrite it. Alright, how many of you feel like you understand now how to do this type of work? Okay, it's not too hard, not too hard.